verbal sentences into algebraic expressions, okay? Now, that's a typo. Hold on. That should say than, not than. Okay. You'll notice we're talking expressions. There are not going to be any equal signs in here. The word that means equal, and you can add it to your keyword list, is is. Is means equals. You'll see that none of these say is anywhere in there, so we're not going to have an equal sign. Okay, we have 2 more than 4 times the cube of a number. So, okay, 2 more than is addition. 4 times is multiplication. The cube, okay, that's going to be an exponent of a 3. And then anytime it says a number, this is a variable. So it's 4 times a number cubed, basically. Okay. The quotient of 5 less than a number and 12. Quotient of means divided. And the order is you take whatever comes first and then divide it by whatever comes second. So the quotient of 5 less than a number, so a number minus 5 divided by 12. Whenever you see this 5 less than, it means minus 5 or minus whatever number. It's not going to be 5 minus something, right? Less than means we take away the 5. So this one kind of goes backwards a little. Okay. The square of a number increased by 4 times the same number. So increased by is addition, 4 times the same number. 3 times the difference of a number and 8, okay? When it says 3 times or 2 times and it says the difference or the sum, this is going to be in parentheses. So it's going to be 3 times the difference of a number and 8. Now, unlike 5 less than where you do minus 5, when it says the difference of, you do the first minus the second. So anytime it's the quotient of or the difference of, it's the first minus the second. Properties of equality, and we're going to use these properties of equality when we're solving an equation. Okay, so reflexive sounds like reflection. And that's what we're going to have. It looks like the same thing on both sides. Exact same order. So 3 equals 3. Okay, and you can remember that one because it looks like a reflection. Symmetric, it's a symmetry. So if A equals B, then B equals A. And notice these are not the same thing on either side, but they'll have the same value. So if 3 plus 1 equals 4, 4 would be the same as 3 plus 1. So symmetric and reflexive get confused sometimes, but with reflexive, it's the exact same on both sides. With symmetric, they don't look the same, but they have the same value. Okay, transitive, we're making a transition through. So if A equals B and B equals C, A equals C. So we're going, like, if A is B and B is C, that means A is C. So we could say if 3 plus 2 equals 5, and 5 equals 4 plus 1, that means that 3 plus 2 equals 4 plus 1. Transitive we won't use all that often, to be honest with you. Mostly we'll use substitution, and substitution is if A equals B, then A can replace B, and B can replace A. So, for example, if x is equal to 3, then I can take 2x and I can say that's 2 times 3, which would be 6.
Doesn't then A can replace B?
Yeah, A can replace B or B can replace A. So if you have two things that are equal to each other, they can replace each other. And this is the property that we use the most when solving equations, substitution. So I'm saying, if x is 3, then 2x is the same thing as 2 times 3. So we're replacing the x with the 3. Use these a lot for solving too. So if A equals B, if I add the same thing to both sides, they stay equal. Or if I subtract the same thing from both sides, they stay equal. That's terrible. So for example,
Is that a D or a 10?
the 10 here?
Yeah.
10. See, if I have 10 is equal to 4 plus 6 and I subtract 4 from both sides, I end up with 6 equals 6. So you can see that if I subtract the same thing from both sides, it stays equal. It would be the same as if I added the same thing to both sides. If you think about the equal sign, not as here's the answer, which is what you grow up thinking of the equal sign, 2 plus 3 equals 5, it's like the answer is 5. Equal is more like those old-fashioned balance scales. The equal is the thing in the middle that it balances on, and they have to stay level. That's what equal is. It says these two sides have the same value. Same with multiplication and division. If I have two things that equal each other, I can multiply by the same thing on both sides and they stay equal. Or I can divide by the same things on both sides and they stay equal. So if I say 2x equals 10, and I divide both sides by 2, it's still going to stay equal. X will be 5. Okay, so if we're solving one-step equations, we're going to do one step. Okay? Always see what they've done. Here they have subtracted. We're going to do the opposite of what they did. So if they subtracted, we're going to add. Okay. If they added, we're going to subtract. Okay, so I'm going to have to add zeros to that. Okay. Now, this one can be solved in one step or it can be solved in 2 steps. I'm going to show you both. With one step, you'll be working directly with the fraction. With 2 steps, we actually get rid of the fraction. Okay, so in working with it in one step, I'm going to take and I'm going to multiply both sides by the reciprocal. Okay, these two will cancel each other out and I'm left with x. And then I can say, okay, 5 goes into 20 4 times. 4 times negative 8 is negative 32.
So you have to flip.
Yeah, well, that's one way. You can multiply both sides by the reciprocal. Or if you want to make it into a two-step problem, we can do that as well. And then you're not actually dealing with a fraction. What you always do first is multiply by the denominator, and you're left with the numerator. Because these will cancel each other out. And then you can divide by the numerator. So this is a matter of preference. If you're comfortable dealing with the fraction and you want to do a one-step problem, you can multiply by the reciprocal. If fractions make you uncomfortable, multiply by the denominator first. That gets rid of the fraction, and you're left with just the numerator and the variable, and then you can divide by that. Also, if you see this is x divided by 4, not x fourths. So to get rid of it, you'll multiply by both sides by 4. So you just do the denominator. Basically, it's the same here, but our numerator would have been a 1. All right, step 1. Will always be distribute if necessary. Okay. We've got 2 distributions. So I get 5x plus 15 plus 2 minus 2x equals 14. Step 2 is collect like terms on each side of the equals. Okay, in this case we don't have any like terms on this side, just over here. So 5x minus 2x is 3x, and 15 plus 2 is 17. Okay. The next thing we're going to do is we're going to use addition and subtraction to get the variable alone. Here we have 3x plus 17, so we're going to subtract 17 from both sides. And then the last step will be multiply or divide. We're going to divide by 3. So x is negative 1. Okay. We'll distribute again. I'll collect my like terms. Negative 10x plus 12x is 2x. I'm going to add 6 to both sides. So 2x is 12. Divide both sides by 2, and I will get x is equal to 6. To solve for a single variable and then it equals a number, you're asked to solve for a variable inside a formula with a bunch of variables. It's the same steps. It's just instead of adding, subtracting, multiplying, and dividing numbers only, we're going to add, subtract, multiply, and divide numbers and letters. Okay, so we want to get B2 alone. That's this guy right here. Okay, we want him alone. So we've got h times b1 plus b2 divided by 2. Okay, this divided by 2 can be the first thing we get rid of. So if they've divided by 2, we're going to multiply by 2. So it gives me 2a is equal to h times b1 plus b2. Now, I've got h times b1 plus b2, so to get rid of that h, I can divide both sides by h. Because it's being multiplied, so to get rid of it, we're going to divide. So that gives me 2a over h is equal to b1 plus b2. To get rid of addition, I subtract. So what I end up is with 2a over h minus b1 is equal to b2. So the same basic steps. The only difference is we're not going to distribute. Because we want b2 by itself, so it doesn't do us any good to actually multiply it by h and then turn around and divide it by h. Questions on that? Okay, on this problem we want to solve for h, so we want to get this guy right here by himself. Okay, so I've got addition, so I can get rid of all of this by subtracting. So I get s minus 2 pi r squared is equal to 2 pi r h. This is all multiplication. So to clear multiplication, I'm going to divide. So I end up with s minus 2 pi r squared over 2 pi r is equal to h.